Hello people, welcome back. In today's session, I'll talk about what is the Taguchi loss function, which we also call as in TGF, developed by Mr. Jenichi Taguchi. So what does it mean? So according to the Taguchi, that every time the process deviates from the target, though it stays within the specification, there is always loss to the society. And when you talk about the society, who lives in the society, there are two people who lives in the society. One is the consumer and the second is the producer. So if it is deviating from the specification, either it's a loss to the consumer or it is a loss to the producer. So this is developed by Jenichi Taguchi. It's a graphical presentation on how an increase in variation within the specification limit leads to an exponential increase in the customer dissatisfaction, or basically in the society. So I'll show you with a graphical presentation the definition deviates from the target. Suppose you have a target value which is like this here. Now you will have the specification as the process says, though it stays within the specification, but it leads to every time the process deviates from the target, even it stays within the specification, there is a loss to society. And if I design the specification value, suppose this is your specification value on the lower side, and here is the specification on the upper side. Let me put this in the green color as an specification, and orange color is your center value. And you now see, suppose here is, I am just adding one more picture. Let's say this triangle. And this is what my process performance is. Let me make it little transparent in the light color. Like this. Okay. So you see the performance, if you see, if it is going here, means the volume is going down, then this is expected that the performance will be moving from left side or the right side because the spread is increasing in the process. If the spread in the process is increasing and you look from the loss to the society, if I represent in this picture, as the spread will come down, then the loss to the society will increase. Like this, it is going down and down and down, which means the variation is increasing. But at the same time, if you start reducing the variation in the process, which means the data points are continuously moving towards the center and they are sinking towards the target line like this. So then this variation on the left side and right side has increased, then the loss to the society will continuously decrease. That's how Taguchi loss function is explained. Now let's take a practical example and understand how the Taguchi loss function calculation will work. So there are two people in the society. One is consumer, another one is the producer. Let's say you being a consumer, you buy something every day. Maybe I'll take an example like as you are buying a milk every day. And approximately you are buying a milk of 1000 ml every day. And because every time in every packet you cannot receive the 1000 ml of milk. So what these things come with a specification value, like as you may have a plus or minus 1% of tolerance. If it is plus or minus 1% of tolerance, which means your lower specification limit will be 1000 minus 1% of that value. Let's say multiplied by 1%. If I do for, let me write a straightforward, 1% is 10. Is the number 990, and the upper specification limit with respect to the 1% will be 1000 plus 10, which is 1% of 1000, which will be 1010 ml. These are the two values. So when you are designing the specification of this will come like, okay, here is my lines. Assuming this is your 990 ml represented in, let's say, black color, and this is your 1010 ml represented in the black color. What is the expectation? Expectation that value should be exactly at the 1000 ml. I'm writing in the green color. So when you start manufacturing, suppose you are a supplier, looking from the supplier perspective. Let's first look from the consumer perspective. That will be better. You are a consumer and you are buying 1000 ml every day, 1 liter of milk. So in a year, you are buying approximately 1000 multiplied by 365. Just looking from the one consumer perspective. So this much of ml, which means if you want to convert this into the liter, the value will be this divided by 1000, which is 365 liter. Each liter cost you, suppose, $2. 1 liter of milk is just costing you $2. So the total amount you are spending, the total spent, the money is 365 multiplied by $2. $730 you are spending in a year. Assuming now that your person who is running this packaging unit for the milk, who is producing the milk there in the factory, understand that what are the benefits of dealing with the specification or playing with the specification, like as 1% tolerance is there as per the government, which means the person is supplying the milk between 990 ml or 1000 ml. You cannot claim anything because that is what the tolerance is given to him. And wanted to take a benefit, suppose this person is now adjusting the specification on the lower side like this. So if you look at this graph is supplying approximately, which is less than 1000, more than 990, maybe 995 ml it's actually supplying. So 995 ml, how much is the loss to you as a consumer on every packet? This is a simple, it's a 5 ml loss because this is what the target is and this is the actual supply. Which means if you look for the 365 days, the total loss, what you are going to have, 5 ml multiplied by 365 days. Right? Cost still remains same, $2. And if I convert this is around 1000 divided by, so it will be 1.825 liter. And 1.825 multiplied by $2, this is the loss around $3.65 you will have the volume you are losing. Now, this is from the consumer perspective when you are an individual. Suppose this person who is running the packaging unit is supplying to at least 10,000 people every day. And from the each person, this person is able to save $3.65 and multiplied by 10,000. So how much is the total saving he is having? Approximately $36,500 he's just saving by taking the benefit of a specification and supplying only 0.5% less than the nominal value to the consumer, though still staying with the specification. So that's how exactly the Taguchi loss function works. And let me show you in the picture again. If I reverse this value, this is what exactly you will see on the internet. And it will be like this. Let me create another one. Insert. And I create this shape. And I start using this value here. And you go like this. So what is the objective? As this value will go either this side or this side. So what you see here, this is the loss to the society. If you are supplying more than the target, this is a loss to the supplier. And if you're supplying less than the target, then this is a loss to the consumer. Objective is always that it should be very well within the center limit of this. This is what the Taguchi loss function. So what we are supposed to do, reduce the variability in the process. So all the value, which means 100% value, stays within the limit and it should be as close as possible to the target value, then only we can save loss to the society. That's about the Taguchi loss function. Practically, how does it work? Thank you so much, and I'll see you in the next session.